Quotient of rational expression. So your objective is that you will study how to find a quotient of two rational expression. So here are some examples, just like the when doing whether you will multiplying or dividing. Here are some rational expressions. Here are some example. So here are steps to that should be quotient. By steps to divide a fractional, meaning the quotients of two rational expression. It's the first thing is you're going to invert the divisor and multiply, and when we look at an example, they will make a little bit more sense. And then we're going to multiply the numerator to get the numerator of the solutions, and then multiply the denominator to get the denominator solution, and then simplify. Again, a fraction can be simplified if the numerator and the denominator have a common factor. So let me fix this and say divide. So steps to divide that, and then this is the quotient. So the quotient of two rational expressions. All right, so let's look at the first example. First example of we want to divide 1/2 divided by 56. The first thing that you want to do, you want to invert the divisor, and you may have heard of this before. The what we usually like to say is that you keep the first fraction, you change the middle, you change your sign, and then you flip your last fractions. So keep the first fraction, change your signs from division to multiplications, and flip it. And that's what we meant when we say invert the divisor and multiply. So we're going to keep our 1/2, change my divisions to multiplications, and then flip my 56 to 6/5. Then second step, say you multiply your numerator together and then multiply your denominator together. So 1 times 6 is 6. 2 times 5 is 10. So 6 over 10, can I reduce that any further? I can reduce that to 3/5. So my answer for that is 3/5. All right, let's look at the next example. What if I have variable x over w divided by w over 3? We're going to do the same thing. I'm going to keep my x over w, change my divisions to multiplications, and then flip my w over 3 to 3 over w. And then we're going to multiply across. 3 times x gives me 3x. All over w times w gives me w squared. Can I simplify that any further? No, therefore that is my answer. So here is the rule. If I have a over b divided by c over d, then I'm pretty much doing a times d, because I a over b times d over c. I keep my first fractions, change my divisions to multiplications, then I flip my last fractions from c to d to c. All right, let's look at one more example before we do our practice. So if I have t over 9 divided by t squared over 2, again, I am going to keep my first fractions to t over 9, change my divisions to multiplications, I flip my 2 over t squared. So I have 2 over t squared. Then we're going to multiply across. T times 2 is 2t. All over 9 times t squared is 9t squared. Now, can I reduce this any further? Yes. I have t and t squared. Again, t squared means this is t times t. So we're going to say, okay, I'm going to cross one out from the top, one from the bottom. So my answer is 2 over 9t. So here is your first two practice problems. Number 1, I have t minus 3 over t divided by 2 over t. So I'm going to keep t minus 3 over t, change my divisions to multiplication, flip my 2 over t to t over 2. Then we're going to multiply across. T times t minus 3, I'm going to say t times t minus 3 all over 2 times t is 2t. Now, can I simplify that any further? Yes, I have t and t, so I'm going to cross those out. Therefore, my answer is t minus 3 all over 2. So that's the first one. Then the second practice problem say that I have 3x over 8 divided by 7y over 4. So we're going to keep our first fraction 3x over 8 times 7y over 4. We change that to 4 over 7y. Then let's multiply across. 3 times 4 is 12, so 3x times 4 is 12x all over 7 times 8 is 56, so 8 times 7y is 56y. Now, can I reduce this any further? As you can see, they're both an even number, so I can divide that. So I can do it by 2, but I can also divide both of them by 4, sorry. So 4, if I divide 12 by 4, I get 12 divided by 4 is 3, so 3x. And then 56 divided by 4 is, let me check that real quick. I did that earlier. 56 divided by 4 is 14. So 3x over 14y is my answer. Alright, example 4. This time I have a squared minus b squared all over a divided by a minus b all over b. So again, we're going to keep, change, and flip. So that's the first step. I'm going to need to keep a squared minus b squared all over a times b over a minus b. So keep, change, and flip. Then we are going to do the next step by saying, okay, now I need to multiply my numerators together, denominator together. So I'm going to say a squared minus b squared, a squared minus b squared times b is all over a times a minus b. Okay. And then, by looking at this, can I simplify this? Before I simplify, I'm going to look at my numerator. Can I factor out my a squared minus b squared? We look at an example similar to this also yesterday. So when I have a squared minus b squared, I can rewrite that as a minus b times a plus b. And then I have the b over there. Then I have, in my denominator, I have a times a minus b. Now, can I simplify it? Yes, I have a minus b in my numerator and a minus b in my denominator. They're going to cancel out. Therefore, my answer for this is b times a plus b all over a. Oh. So let's simplify. What if I have x squared minus 3x plus 2 all over 4x divided by x minus 2? Now, if I have x minus 2, what's going to be my denominator? That we understood to be there is a 1. So now we're going to keep, change, and flip. So this is equal x squared minus 3x plus 2 all over 4x. Change my divisions to multiplication. Flip that to 1 over x minus 2. Okay, then we're going to multiply across. X squared minus 3x plus 2 times 1 give me x squared minus 3x plus 2 all over 4x times x minus 2. Now, can I factor my numerator? Let's look at my x factor. I have negative 3 all over 2. Okay, what are my common factors of 3? My factors of 3 is 1 and 3. Therefore, this is 1 and 3. Now, I need a negative 3. Therefore, one of my answer has to be a negative. 3 minus 1 or 1 minus 3. 3 minus 1 will give me a positive 2. Therefore, I'm going to have in my numerator x minus 1 times x minus 3 oh, I did this wrong. Sorry guys. So I was like, doesn't make sense. I did that wrong. I apologize. My C is supposed to be in my on top, and then my this B has to be in the denominator. Sorry. So here then I need to look for some factors of 2. 2 times 1 is 2. Since this has to be a negative, they both have to be negative, because negative 2 minus 1 is negative 3. So my answer should be x minus 2 and x minus 1. All over 4x times x minus 2. Then you can see here that we have x minus 2 and x minus 2 that cancel out. So my answer for this is x minus 1 over 4x. Go ahead and do your practices. So practices 3, 4, and 5. Right, number 3, I have y minus 3 over y squared divided by y squared minus 9 over 5y. So we're going to set this equal to y minus 3 all over y squared times 5y over y squared minus 9. All right, we're going to multiply those two. So I have y minus 3 times 5y all over y squared times y squared minus 9. Now I have y squared minus 9, so I can factor that. So let's factor that. I have y minus 3 times 5y all over y squared times y squared minus 9 gives me the square root of y is y, square root of 9 is 3, so y minus 3 and y plus 3. Alright, then my last step is, can I simplify that anymore? I have y squared and y here, so I can say cancel that one out y. I'm left with 1y. Then I can also cancel out y minus 3, y minus 3. Therefore, my answer is 5 over y times y plus 3. Alright, next one. I have k squared minus 2k over 3 divided by k minus 2 all over k. So we are going to keep k squared minus 2k all over 3 times k, change my divisions to multiplication and flip my k minus 2. Alright, I have k squared minus 2k. Do they have anything in common? Can I factor out? I can factor a k, so I'm going to go ahead and factor k, and I'm left with k minus 2 times another k all over 3 times k minus 2. Now, can I factor anything? Yes, I cannot factor. Can I simplify anything? I have k minus 2 divided by k minus 2. That gives me 1. Therefore, k times k gives me k squared all over 3. And then our last one, I have w squared plus 6w plus 9 all over 12 divided by w plus 3. Again, when I have w plus 3, my denominator it's 1 that we usually don't write right there. So I'm going to set this equal to w squared plus 6w plus 9 over 12 times, change my divisions to multiplications, flip it to 1 over w plus 3. W plus 3. Alright, and now we're going to see if we can factor this out. Can I factor w squared plus 6w plus 9? My 9's go on top, my 6 go on bottom. Some factors of 9's are 1 and 9. I cannot do 3. I can do 3 times 3, and I can see that 3 times 3, 3 plus 3 will give me 6. So my factors are 3 and 3. So I can rewrite this as w plus 3 times w plus 3 all over 12 times w plus 3. Now I can see that I can cancel one of my w plus 3 out. Therefore, my answer is w plus 3 all over 12. Alright guys, I'm going to go ahead and do the summary. So in summary, to find the quotients of the two rational expression, you're going to invert the divisor to multiplications, or in other words, keep, change, and flip. Then you multiply your numerators together, multiply your denominators together, and then check to see if your expressions need to be simplified. If it needs to be simplified, then you are going to simplify it. And then lastly, here is your homework.